Yeah, I'm Nate Butterworth. You know, my background's geoscience, so this is definitely outside my domain expertise. But it's been sort of interesting to explore and unpack Aeneas and what it can do and everything. I think it's really fascinating. But yeah, I'm not part of the DeepMind team or the Aeneas team, so all the opinions are purely my own. And yeah, I have you two read the paper?
Yeah.
Haven't had time. Yeah.
It's I think quite you know, there's 28 pages. Most of those are methods though. So the gist of it though, for your sake, is that, and this is what I've learned, and that I think is pretty cool, is that inscriptions were kind of everywhere in the Roman world. You know, they're and there's 1,500 new inscriptions discovered every year, and they range from everything from like official decrees of emperors, all the way to enslaved individuals and graffiti on walls and everything. And so obviously over time, the letters and words and the context of all those things have been sort of lost to time, as you'd imagine, to weathering and whatever else. And things get displaced, things get moved around. And so that was the motivation for this tool, Aeneas, which basically gives or tries to contextualize and find parallels, so similar sort of items, I guess, and similar inscriptions from like known databases, and try and understand and bring all that stuff together. So that's the Aeneas goal. And there's a few things that it does. So previous work kind of focused on, you know, filling in the blanks. So if there was some sort of scratched out, defaced inscription, it would do its best. So traditional machine learning will try and just fill in the gaps of what's missing. But yeah, Aeneas sort of adds a few layers to that and tries to find not just the reproduction of the text, but it also tries to find similar parallels, and also define where the inscription likely came from. So and also give it a time period. So a time period, a place, and also fill in the text. And I think that was sort of a new thing that hadn't been done before. Does that all sound right so far to everyone?
Yeah. Oh, sorry, you go, Jenna.
You go.
Mm-hmm. I was going to say, is the geographical location, is that due to like colloquialisms in Latin and Greek by area, or it's just interesting?
Yeah, I think some of it. That was the other thing. I think like there's a lot of like slang words or something used in Latin. I mean, I'm no Latin expert, but I think they're all like different terms for different things, misspellings and so on.
Well, there's lots of misspellings, but where are they getting context from? I haven't actually had a chance to read this, but because we're missing a lot of context for a lot of inscriptions.
Yep, and also, okay, so we can talk about the limitations of the model, but one of the things is that this is trained on I think it's here, so it ends up being, I think, about 170,000 inscriptions, combining these three data sets: the epigraphic database Roma, the epigraphic database Heidelberg, and the epigraphic databank Klaus Slaby. And so it cleaned up all those and normalized them in some way. It did say, I imagine that would be probably one of the hardest parts of this endeavor, was pulling all that data together. And if people could have their own databases or something in other languages, then adapting this model apparently is not too onerous. So keep that in mind if people are have other data. But yeah, so
they're the main three databases that people who've been inputting stuff into, because everything else is in huge volumes, paper volumes,
sure.
which is very, very laborious to use.
And that, I think, is written down somewhere, that it's a motivation, that just handing people the database was a big step forward and helpful. And oh yeah, but so one of the problems or the bias that comes out of the model is that we have to assume that those inscriptions, everything in that database, is correct and has been already interpreted correctly, which may or may not be the case. So yes, and yeah, we're talking about Latin here. I think so. This was built upon an older model called Ithaca, which is based on Greek texts, and so they then used the Latin database and updated the computational model of the Greek one, applied it to the Latin database, and then reapplied it to the Greek database. So they've sort of updated that old one called Ithaca, and released the Latin one. So, and we can go through some examples soon. So yeah, what else is interesting about it? I think okay, so there's I mentioned there's sort of 3 parts to the model. It takes input and an image, and it operates on characters. So previously, I think a lot of models operated on full words or sentences, or trying to do the whole inscription in one go. So this operates on individual characters, and then the driving force of the model is there's a couple special characters that you include, either a dash or a question mark, I think, and a hash symbol to designate whether you know how many characters are missing, or whether there's an unknown length of missing characters. And so they talk about this thing called the torso of the model, which is what's known as a T5 transformer, which is a type of AI sort of model. It's nothing groundbreaking for this research. It was when it came out, but it's just the way the sort of the model is constructed. The neural network is constructed, and it uses these transformer models, and then it has these output heads. So they talk about these 3 output heads, which is the restoration of the unknown character length. So that's the restoration, the geographical attribution, and also the chronological attribution. And so if you're using a tool like Gemini or ChatGPT or something, you type in words and you get words back out. So that's a text-to-text model, but you can also ask, make me an image, and that's a text to image model. And so or you can put in an image and say what's in this image, and that's a image to text model. And so this one in this case is a text and image to text, geography, and time model. So yeah, these, I guess it's a bit unique in that those output heads and the input and output compared to other sort of AI models, but the way that it does it under the hood is very similar. So it's still it still uses the same sort of neural network model that things like Gemini and ChatGPT use. So there's just a bit of background for you. Oh yeah, so I think this is describing how that model sort of works in some high-level overview.
So really, because you wouldn't appreciate this with the short time period that we've had ChatGPT and Gemini and things like that, but it was what struck me is, given the time period which this operates on, which is like 1600 years or something like that, and then the geography which it operates on, which is kind of populations, but the ability to communicate is not that readily available, and hence the language kind of diversifies. And the way this seemed to work, to me at least, is to actually work out what the text is based on where it could have come from.
Yep, absolutely. Yeah, and just unpacking a bit sort of how this model works. If you're not familiar, it uses something called embeddings. So if you say do a search, a general fuzzy string matching search for two words, something like, you know, car and train, that you won't find that they're related, but your neural network in your brain, you know that they're both like modes of transportation. And so embeddings in AI models, that's kind of how they work. They find associations between things which are contextually relevant, and so and it projects these embeddings into some higher dimensional space and tries to group them in related areas. And so it will keep things like the places and the periods and the related concepts and synonyms and formulaic variations and puts all that together for each individual inscription, and then we'll put and make those connections between each other. And so that's what an embedding is, and that's the real power of the model. Okay, and yeah, and then they talk a lot about how the real power of it comes from I think this is all the like sort of how they did it. They sat down with, I think, 23 researchers and gave them tasks and said, oh, can you please try and contextualize this inscription and restore it, and then they gave Aeneas the task as well, and then they did it together. So they said, okay, here's Aeneas, and gave Aeneas the tool to researchers and said, can you do it with this? And that was found to be the best result. So this table describes the results. Yeah, historians working on their own only scored a 39%. So that's basically how many they got incorrect. So 0% is the best for this score. Aeneas on its own only got 23%, but then historians working with Aeneas got 21%. So that was the best way to do it. And then there was similar sort of metrics that they measured, but that was for the restoration, for measuring the date on its own, and then also like confidence and how many similar items or similar parallels they found in the database. So a few different metrics there they used to sort of benchmark it and prove its usefulness. Yeah, so people seem to like it. So I think, okay, and then yeah, then they do this example of grounding the res gete divi augusta. How's my Latin? And I think that the example is robust and fine. They have the probability of when this particular inscription was likely inscribed, or where it was formed, and sorry, when it was formed, and also where it was formed as well. So there's a few different locations that you get, and that's the thing. The way also Gemini and GPT, these models, they create probability distributions. Every time you ask it a question, it will give a probability distribution for the most likely response, but it only ever exposes the number one to you as the end user. But with Aeneas, I guess it knows that, you know, the first one's probably incorrect, so it actually, like by default, it exposes that distribution underneath it, and then you as a historian can go and sort of explore and see what other options sort of came out in the process. Okay, let's see. Do you want to talk about anything else? Otherwise, I can do a demo. There's a bunch
how does it do the resolve text of unknown length?
How does it find?
Yeah, because like the panel at the top of the paper, so you know the half inscription, is if you kind of look at that, just the inscription, is there's an unknown width to it, and an unknown height. So how does it manage to resolve that there is another 4 words after it?
That will be based on similar inscriptions, because this is official inscription set up to an emperor.
Okay.
So it will be from knowing their official title.
Right.
Okay.
So that's where the parallels come in. So on this site, there's a couple ways to interact with the model. This website's probably the easiest, predictingthepast.com. You can go there and jump straight into Latin or Greek and launch it. And then it's as simple as scrolling down, and down here it says, please enter at least 25 characters. So I think it does 25 up to 750 or something. Use a question mark for each character you want the model to predict, and use a single hash to predict sequences or unknown lengths. And use a dash for any missing sections or characters in your text that do not need restoring. Okay, so yeah, if I just use one of their examples, but Jeanette, you might have some of your own. And then I think if you click contextualize, restore an attribute, it should only take a second on these examples. It can take several minutes if it's a more complicated one. And then it pulls out a bunch of parallels. So these don't make much sense to me, but hopefully someone who's more involved in this will understand, what this piece is and what it means and how relevant these are to that particular inscription. And then here are the restoration outputs. So these are the basically that probability distribution I was talking about, where it says, okay, here's to reconstruct text. So that was our missing characters, and the first one is templum mar that it thinks, and then there's a bunch of other options as we go down, and so I think it gives 20 by default, and then so here's kind of going back to your question, Paul. How does it know? This gives what's called a saliency map. So I hadn't heard of this before, but it's it's basically what the model used to used mostly to predict the missing characters. So some of you can imagine that the text immediately around the missing parts probably is most important for filling in the gaps. But so the stronger the color, the more useful it was in predicting the missing bit. And then other parts of the sentence are also used in it. So yeah, and that's for each character. So T and then a space and it's an L, and so for each one, different characters are used. Which is, I think, yeah, a nice visualization. And then it gives you the geographical distribution. So there's a map. Maybe that was a bad example. There's often other dots, but this one is very strongly predicted in Britannia. I think, yeah, there's like 63 domains or something that it can put it in. So it's not like an exact location. And again, then it gives you a saliency map for the geographic distribution. So which letters of the text were used to predict where the inscription most likely came from. And then finally the timing. So there are your 3 sort of outputs. So it gives a guess for where the when this inscription was created, and again gives a saliency map for that. So that's on that. If you want to get down into sort of more details and also upload your own images, then you need to use the Python notebook. which I think can be rather intimidating, but it's basically the same thing. So this is what a Python notebook is. I'm just going to hide the details so it's a bit clearer on my screen. But it talks you through it. It obfuscates all the code, so you don't even need to look at the code, but it just gives you a couple more options. So I'm just going to click play. I guess it says yes, run that anyway. So basically, yeah, it has some preamble here, and then you click these play buttons, and it gives you some instructions for how to use each, how to use this notebook, and you can select, Latin or Greek, and then in this case, yeah, you have to sort of run all these installers and imports. I'm just going to click all those, and the exciting part comes down here. So on the website, it does all that sort of in the background. It's sitting on some web server, and it's already done it. But down here, it has some examples already to go with optional, with a few more options. So you can adjust things like the randomness of the model, so how like crazy it's gonna think, and you can upload the image. So you can select an image and upload that. And then you get those three output heads: the parallels, the restoration, and the saliency. So let's see. Okay, so that's all finished. That only took a second. There's a bunch of errors there, but they're actually not bad. So I'll just click play on that as well. That one's done. Don't have an image, so I'll skip that one, and I'll click parallels. So this will come up with that, probably a list like this, like we had before, from the database. And in fact, if I open up the folder on here, I can actually, like, these are it's downloaded the model files, so the files it needs to run the model, and it actually downloads the entire data set as well, which is a big JSON file. So all these parallels sit in this JSON file, which I think is pretty big, but it does open. But now my thing's frozen. Any questions about this?
It looks very useful. I just need time, and this last bit with Python I don't really understand.
Yeah, no, that's totally understandable. It's like I said, yeah, I think the website is pretty good. It's only if you want to drill down and tweak some options and parameters a bit more. That's the tougher part. And I think that there's also another website which is all about education. So all these links are kind of in the main blog post. But yeah, this is about how you can use it for education and teaching. And then there's another notebook that's attached to that, which is a little bit more friendlier, I think, than the other one. But it's still, yeah, lets you sort of do a few more things. I'll go back to this one. So that's still thinking. But yeah, it's exactly the same as the other website. The restoration, the saliency map, the geography plus the attribution, and then the saliency map, and then the chronology. So it's those three sort of outputs whenever that comes. And the way I've learned all this is using something called Notebook LM. If you haven't used this before, it's fantastic. I ask all these different questions. I put in all the sources over here of the paper and the website and stuff, and then ask it questions about the paper.
So is that a Microsoft one?
This is a Google one. So
A
Notebook
Google one.
LM.
Google.
And actually, you can go to that if you like and consult my notes and play around with that.
it's really good at just taking a discrete set of literature and
Yeah.
probing that, as opposed to having the whole internet when you go through text.
Yep.
Because I haven't really used AI very much, but its use for things like restoring inscriptions seems to have very important applications for future understanding of things, I think.
Yeah, well, I think you're the target market for this because it's supposed to be accessible with you know, the web interface, and hopefully it's a tool that you can use. Well, there we go. So yeah, that step takes the longest, but we get our different predictions out, and you know, some of them vary quite a lot. I imagine if you knew what you were talking about, unlike me, some of these might make sense, and some, you know, with some more information, they might be more relevant than others.
Most of my inscriptions are very different. They're funerary, but one of my postgrad students I know has an inscription that's no one's been able to translate or, you know, fill in the bits. So I can see, yeah, it's a very exciting applications.
Yeah, that's interesting. Okay, so we didn't get the geographical attribution because I think we need to define an image if we want to get that result back, I think. But I'll rerun.
I think because sometimes lettering can change over time. Also, you wouldn't be able to analyze a stone because that's an invasive process, and you might not actually have the inscription anymore.
Yeah,
I think that's why they want the image of the text, is because it can change.
yes, which I don't have an example of, but yeah, I think that's kind of the nuts and bolts of it. Anything else you want to talk about?
I have to go, but I'm sorry, I've had one of those weeks this week. I didn't have time to read any of that, and I still have to figure out whether I can get in, but it's very exciting, and it's actually nice to say hello to somebody somewhere else who's fascinated by this.
Yeah, that's good. Well, yeah, 34 people registered for this. So I'll share all these links and tools to those 34 people anyway. So
yeah,
hopefully a community of interest arises out of that. But yeah, reach out if you have any questions or you get a chance to play with it.
Yep.
Hi. Actually, I have one question regarding the notebook LLM. Could you please open that?
Yep.
So you showed some parameters over there for tweaking the results related to like temperature and all.
Oh, right. Okay, that was on this one, I think. Here?
Not this one. The Python notebook you showed.
Oh, that's the Python notebook. Yep.
Yeah. So in here you showed these parameters. So actually I'm attending one training on Gemini. There are some like for the encoder and decoder, they have some parameters like temperature, top P and top K. Are these the same ones or different from them?
They're the same ones, so they influence the model in the same ways. Yeah, so temperature, and top K is about getting how many results you want. So this is kind of the top K. Top P and temperature, they both kind of do the same thing. They're both they're related to the entropy of the model, so how creative the model can be. So yeah, tweaking those is an art, I guess. But yeah, they both kind of do the same thing. I think temperature.
Okay, so what about these width and restoration length? What does these do?
Waiting for you to ask me that, and I don't know the answer. So width, arg beam width. So I just click show code to see what it is. Let's have a look. I'm going to ask on my notebook, what is arg beam width? Let's see if there's an answer there. Don't know what it does. It might be how it relates to like how far the search looks for the like how distant from the missing characters it will look for relationships or something like that.
Okay.
Yeah, that's so the restoration length, I guess that makes sense. She could even say it in the instructions. Maybe. Yeah. Hard beam width. We get a it's a parameter used in the interactive notebook that sets the beam width for the model's beam search algorithm. The parameter is specifically used when generating textual restoration predictions for damage restrictions. Beam search is the method Aeneas uses to generate multiple possible restoration hypotheses. So the beam width determines how many of the most likely candidate sequences or beams are kept for each restoration sequence. Okay, so it's like a top K parameter. So in the provided code and document, default value is 100. This means that during restoration, the model maintains and explores 100 most probable hypotheses at each stage to arrive at the final rank. Oh, right. Okay, there you go. It's very useful.
Yeah.
Okay. Let's see what I think I had. Anything else that we want to cover? I think kind of spoken about most things. Spoke about some of the limitations that the data set. Oh yeah, so the data set size 170,000 sounds like a lot, but it's actually not that many for a like Gemini is trained on probably billions of tokens. So 170,000 is a relatively small amount. And yeah, we mentioned there's other limitations. Yeah, I think that's it. So yeah, Paul, definitely share with your colleagues. I think I think a few people from Macquarie may have registered. Hello, Scott. We were actually just sort of wrapping up. If you're there, Dame Nilly Lunchalot. Yeah. Any more questions or?
No, that's great, mate. I'll have a wander through it again. So I'm a bit dry on Latin inscriptions to test in it though, but
yeah, that was same with me.
it's like I just go to my collection of Latin inscriptions which are missing text. So no, I did wonder it would be interesting how you could take the essence of the model and abstract away from it. Because about like in effect, it read to me about a localized variations and trying to unpick them. So it's almost like if you were to think to something like Gemini and the ability to play back, if you have, a very localized subset of a language like a dialect or something like that, it actually could, and there's enough people using it, it actually could play back to you in your own dialect as opposed to just in plain English.
That would be cool. Yeah. We actually had a talk last week on Aboriginal English in like AI models and sort of how people are working on that currently to get the dialect and the slight language variation correct in AI models, because they're trained on and delivered in very specific languages.
Mm.
So, yeah. Yes.
Good.
Good stuff. All right.
Thank you
Well,
for your time.
please reach out if you have any questions. Otherwise, have a good day, everyone. See
Yeah.
you soon.
Cheers all. Bye.
Bye.
Thank you so much. Bye.
Cheers.